What is going on, ladies and gentlemen, boys and girls, children of all ages? I am the original gamer, Steve Bistro. And why am I here? Well, I'm here to work with you on how to program in BASIC on your Radio Shack TRS-80 color computer. This is a series I started a little while ago, and it's a series I have been dragging my feet on updating. So today I'm doing 2-for-1 episodes. I just recently uploaded Chapter 4. We are now on Chapter 5, which is called Watch the Clock. So let's go ahead and jump in and see what this chapter is all about and what it is going to teach us. And so the first thing it's showing us right here, if I zoom in for a second, it says you are now ready to show your computer how to tell time. Type in 10 for z equals 1 to 460 times 2, next z, and then print I counted to 920. What the heck are they talking about? Well, they're going over that whole for next loop we just talked about in Chapter 4. They're having us count to a specific number, which is 920. And let's go ahead and play their little game here. And let's type in the code and let's see what happens. So we're going to type in 10 for z equals 1 to 480 times 2, 20, next z, 30, print, quote, I counted to, I can't read that, it's too darn small. I counted to what? I counted to 920. All right. Is that right? 920? 480? Wouldn't that be 960? I don't know. 48, 96, but it says here I counted to 920. Let me make sure I'm reading that correctly. It says, yes, I counted to 920. Somehow I think, 460. That's my first problem there. I can't read it. It's actually 460. So pardon me for having a hard time reading that fine print. So I counted to 920. So let's fix that and let me fix my code. 920. All right, let's go back. 10 for z equals 1 to 460 times 2. Let's list that out again. So here we go. So for z equals 1 to, where's my mouse? For z equals 1 to 460 times 2. Next z, print I counted to 920. That's what it's asking me to do. Let's run it. Okay, we're waiting. I counted to 920. Let's list that again. It basically said count to 460 twice. So it's basically telling the computer to count to 920. So when I run that, 1, 2. Took about 2 seconds. I counted to 920 is what it comes back and says to me. So what does all that mean? Let's go back here for a second. Run the program, be patient. Wait a couple of seconds. 2 seconds to be precise. It takes your computer 2 seconds to count to 920. Lines 10 and 20 set a timer pause in your program. Make the computer count to 920. This will keep your computer busy for exactly 2 seconds. Interesting number they came up with there. And as you can see, the groundwork, and as you can see, this is the groundwork for a stopwatch. Erase the program and type how many seconds, input S, and then basically 460 is the counting for 1 second. So for your computer to count to 460 takes 1 second. So what does that mean? Let's go ahead and do the code here real quick. Let's switch back to a bigger color computer screen that we can see. So clear the program, type in new. 10, print, quote, how many, I guess you have to put in the O for how, there's no repeating keys here, how many seconds, question mark, 20, input S. That's going to input a numeric variable that's known as the S key. 30 for z equals 1 to 460 times S, which is the number of seconds that we input. 40, next z, 50, print, I gotta zoom in on that because I can't read it. 50, print S seconds are up. So we're going to print S, which is the variable. Print S, quote, seconds are up. So what does this look like when we run it? How many seconds? If I type in 1, it'll count to 1. It'll say 1 seconds are up. If I type in 5, it'll, oops, oh, I just wrote a line of code there. If I run the program and I type in 5, 1, 2, 3, 4, 5. My seconds are a little bit different. All right, so 5 seconds are up. But yeah, so basically, whatever number you type in there, if I said 3, 1, 2, 3, 3 seconds are up. So it looks like the magic number for your computer is 460. So 460, to have your computer count to that number takes exactly 1 second. That's kind of interesting. And so knowing that could enable you to get your computer to pause at certain times. So just a little anecdote here. This logic and this way to measure time and to count cycles, this was good when we lived in a world where there was only one CPU. We all had the same CPU, and the CPU ran at exactly the same speed for all people. And so this is really was only good back in the early 80s. This particular Color Computer 1 and 2, which ran from about 1980 to about 1986. I think it was 86 when the Color Computer 3 came out and the processor was actually faster. So for 6 years, we had the exact same processor running at exact same speed. So using the speed of the processor as a way to measure time was acceptable. When processors started to get faster, the faster they can process, the less time it takes it to count these numbers. So using your processor speed as a measurement stick is not the best way to do it. I discovered this the hard way when I started writing games on the IBM PC compatible stuff, and I was running my code on 3 different computers that had 3 different processors. I used to use a counter, and I'd say, all right, by the time you count to 100, it's time for you to do something new. The slow computers took a second to count to 100. The faster computers took less time to count to 100. So counting and using your processor as that measuring stick is no longer good in the modern system. And so what I had to rely on was actually a real-time clock. And the modern PCs have an internal timer that is real-time clock, and you can actually measure time and just wait that way. In the old days, before we had real-time clocks, we had to count, and we had to figure out, based on the speed of our processor, how long it took to count to a certain number. I don't know if that made any sense or if anybody cares about that. But anyways, I'm too lazy to edit that out, so it's going to stay. So there you have it. Let's go back to what we were doing here in the book. And so here it's just giving us a suggestion for a do-it-yourself program. It would help if the stopwatch could sound some kind of alarm. Add lines to the end of the program to give it an alarm. Okay, so that would just be line 60. And so basically I could just say line 60, sound 128, 8. It's picking a mid-range sound and a relatively short thing here. So if I type in run again, and it says how many seconds, and I say count to 5. 1, 2, 3, 4, 5. There's the sound. 5 seconds are up. So it asked me to do it yourself and to make a sound at the end. Now that was my interpretation of that request. What did they say to do here? Well, it looks like they're getting a little bit fancier here. Here's the program we wrote. How many seconds? Input S. Next, print seconds are up. For T equals 120 to 180, sound T, 1. Next T for, okay, go to 50. Well, they actually got a little bit more annoying with that. So let's go ahead and type in their code there. I just made a sound. It's actually making us do something a little bit more crazy than that. So let's go back and list that out here. What are they asking me to do here? So they're actually saying, okay, 60. For T equals 120 to 180. That's about mid-range in the pitch because 128 is about dead center. 70, sound T, 1 80, next T. So that's going to go whoop. It's going to go higher. 120 says go to 50. 50 is the one that says print S seconds are up. So what's going to happen at the end, if I say wait for 5 seconds, it's going to say 5 seconds are up. Whoop, whoop, whoop. And it's just going to keep repeating that. So let's try it. Let's hit run. How many seconds? 5 seconds. 1, 2, 3, 4, 5. Okay, so that's the alarm clock. All right, notice the go-to line at the end of the program. It causes the message to keep printing the alarm until you press the break key. What is the break key on our VCC emulator? It is the end key. End key on your keyboard will break out of the program. I actually found that to be rather annoying, but that's okay. The other thing I wanted to comment on very quickly too is just to follow up on something we talked about in episode 4. How do you pause? On the Real Color computer, it was Shift-At. On VCC, running on your Windows PC, it's actually Shift-Alt. So you'd press Shift on your left keyboard and the Alt or ALT key on your keyboard. Pressing those two keys together will pause your program, and pressing Alt again will unpause. I tried to record a video of doing that, and every time I did, it messed up my recording program, so I can't show you, but just know that's what it is. So now we have done the first little crazy program they've asked us to do. And now there's another one. So now we're going to basically say counting within the time. Before doing more with the clock, we have the computer keep count within the time. This concept will become clear to you shortly. Type in this new program. Let's go ahead and type in new. I'm going to zoom in on the book because I'm having a hard time reading the book. All right, and so the screen's going to be a little bit smaller for just a second. But this is the program we're going to type in. So 10 for x equals 1, 2, 3. 20 print quote x equals quote x. Okay, now we're going to do a loop inside of this loop. 30 for y for y equals 1, 2, 2. 40 print comma quote y equals end quote y. 50 next y. 60 next x. Let's look at this code, and they're actually going to show us what's going on here, but let's look at the code here. It's number one, it says notice the comma in line 40. If you try it without the comma, it's going to print on the next line. If you try it with the comma, it's going to have it skip a column. So we're saying basically count from 1 to 3. So here's our 1, 2, 3. And that's our 4x, and this is our next x. Inside here, there's a y loop inside the x loop that says for y equals 1 to 2. So on the outside here, we're counting to 3. In between each of these, we're counting to 2. So it's a counter inside a counter. So you can this is what's called nesting. So you had your initial loop that said start here and end here. In between, you can cram all kinds of other things, including more loops. The way you close the loops, or the way you can step through the loops, is by saying next and then the variable. So we're doing the y first. We're saying next y, so complete your y loops, and then complete your x loops. Sounds kind of crazy. Let's go ahead and run it and see what it looks like. So our screen output here is almost identical to what we saw on the page, right? So if I just try this again, if I hit CLS and I run the program, right? So this was my x and y loops. This was my x counting from 1 to 3. In between each one of these was my y counting from 1 to 2. Because I printed these with a comma, it actually tabbed it over to a second column. And so it's just kind of a way to put a loop inside a loop, which is kind of interesting, and it's pretty cool that they're actually giving it to us here visually so you can see that. So that's the hokey pokey right there on what they were trying to show us here, which is counting within the time. It's a loop within a loop, which brings us to the next page, which, and I'm having a really hard time reading this, so I'm going to zoom in. Call it a count within a count or a loop within a loop, whatever you prefer. Programmers call this a nested loop. this is what the program does. It counts x from 1 to 3 each time it counts to x. It prints the value of x. It counts from 1 to 2 each time it counts y. It prints the value of y. Whenever you put a double loop inside a loop, you must close the inner loop before closing the outer loop. So they're kind of showing you that here. So it's saying next y, we close the y loop before we close the x loop. This is the right way to do it. This is the wrong way to do it. Now, it is asking us to make a clock. In order to make a clock, we are going to go from 0 to 59, which is our 60 seconds. We are going to make a sound. We are going to pause, and then we're going to print what the sound is, and then we're going to say 1 minute is up. So we're going to do this 59 times. So what it's basically asking us to do is to count to 60. 0 through 59 is 60. It's first going to ask us to print the number so we can see the second. S is for seconds. It's then going to make a sound, the same sound, a tone of 150 for a length of 2. And then it's making us pause inside there. So the sound is actually occupying a small slice of time, but then we have another pause on top of that, which is 390. And the combination of the sound length and the pause length is going to make the computer wait an entire second. It's going to do this 60 times for the duration of a minute. So I understand what they're saying. Hopefully this will make sense once we do it. So here we go. So we type in 10 for S equals 0 to 59. These are our 60 seconds. 20, print S. 30, sound 150, comma 2. 40 for T equals 1, 2, 390. 50 next T, which means just wait until you've counted that much time. 60 next X, or next second. 70 print, quote, 1 minute is up. If we run this, 0. These are our 60 seconds. These are the days of our lives. Exciting stuff, folks. And just think, we have to wait for this to happen 30 more times. Never has 60 seconds felt so long in my life as I'm sitting here watching it count before my eyes on the screen. Oh yeah, so what have you done today? Yes, yeah, me too. Yeah, mowed the lawn, took out the trash. Yeah, fed the dog. Got the kids to school. Yes, 59. Thank God. That was the longest minute of my life. So 1 minute is up. It says it counts from 0 to 59. Each time it counts 1 second. It prints the second. It sounds a tone. It pauses long enough for 1 second to pass. When it finishes counting all the seconds from 0 to 59, it prints the message saying that 1 minute is up. Yes, it does. You're telling us what you already showed us. So there you have it. That is a way to write a simple little program to get your computer to count for a minute. We're now moving on, and now it's getting even more crazier. Now we're getting loops inside of loops, and my head is starting to spin. There's a way to make your program look a lot better. And add this line to clear the screen. Let's look at our current code right now. If I type in list. Okay. So 10 is from 0 to S. From 0 to 59. 20 says print S, but it says type in line 15 CLS. So it will clear the screen each time. It clears the screen. Prints the second line. In 20, it makes a sound. In 30, it pauses long enough for 1 second to pass. In 40 and 50, when it finishes counting all the seconds from 0 to 59, it prints. So using this groundwork, it's easy to make a full-fledged clock. And so they're showing us a program here for hours equals from 0 to 23. That's our 24 hours. For minutes equals 0 to 59. We have 59 minutes or 60 minutes in an hour. And then for seconds, 0 to 59. And so we could print the hours, the minutes, and the seconds, and we could let this thing run. and we could watch it print time as time went on. I am not going to sit here for 24 hours to record the whole thing, but just for grins and giggles, let's run through it one time and let's see what the heck they're talking about here. So we're going to new our program. So 10 for h equals 0 to 23. Those are our 24 hours. 20 for minutes equals 0 to 59. That's our 60 minutes in an hour. And then 30 for seconds equals 0 to 59. That's our 60 seconds in a minute. All right, 40 CLS. 50 print quote h colon quote. Oh no, so this says print h, then print quote colon quote, print m for minutes quote colon quote, s for seconds. 60 sound 150 comma 2. 70 for t equals 1 2 375. 80 next t, because we've got loops inside of loops inside of loops. Then we have to then close the second loop before we close the minute loop, before we close the hour loop. So then we have to say, okay, 90 next s for second. Okay, I screwed up on 80. 80 was supposed to be next t. So 80 next t. 90 is next seconds. 100 is next minute. 110 is next hour. And so what will this look like when we'll watch it for maybe a little bit? I'm not going to watch it forever, but when we run it, there's our time. It's counting seconds. If we sat here long enough, those seconds would turn into minutes, and if we sat here long enough, those minutes would turn into hours, and if we sat here long enough, those hours would turn into 1 hour to 2 hour to 3 hours, all the way up to 24 hours. So we could sit here and have our computer count time for us. It's interesting. The problem with this being in BASIC is that right now that this monopolizes our whole computer, and we really can't do anything else with it while this is happening. So while this is a cool exercise in showing you how your computer, the computer processing speed can be used to calculate time and to measure and pause for time, there's not a whole lot of real world use for this. Now, if you look at some of the notes here on the bottom of the page, it says if you added line 20 going back to 10, this would run forever. It says having a tough time with this program, skip it for now. It will seem easy later. Well, it's too late. We already did it. We've already punished ourselves. Thanks, book. Appreciate that. Okay, so we're back. We're done with this. How do we get out of here? We press break key or end key on our emulator, and we get out of that that cool thing there. So what do we end up with here? And that's kind of the end of the chapter. Wow, how anticlimactic. An entire chapter about how to waste our time watching time. But really the more important thing is understanding that your computer has a clock speed, and that speed is based on how long it can process. That speed is constant. On the old processors, they ran in a cycle, whatever their clock speed was. If it was a 1 megahertz processor, that meant it processed 1 million times per second. The different applications were able to do things based on that speed. So there's a little bit more in here. Let's look at one of these other do-it-yourselfers in here. Between lines 90 and 100, you can add some tones that will sound each minute. I'm not going to do that. Write a program that makes your computer show each of its 9 colors for 1 second each. We could do a CLS. Okay, that's a separate program, right? So write a program that makes your computer show each of its 9 colors for 1 second each. Let's do that. I am not going to add more tones in between there, but let's do that. We'll do the 9 tones and we'll pause for 1 second. I completely forgot. Was it 460 was 1 second? I think it said that it was 460 was what it took to count for 1 second. Yeah, so 460 is 1 second. So the do-it-yourself question is asking us is this. It's saying write a program that makes your computer show each of its 9 colors for 1 second each. So let's go ahead and try that just for grins and giggles, because this chapter was actually kind of lame. And let's do something slightly more visual than just counting time. So let's do new. Okay, so here's our challenge. 10 for C equals 0 to 8. These are our 9 colors, starting with color 0 through color 8. 20 CLS, and we can put C in parentheses. We can leave it out of parentheses. CLS C. 30. Now we're going to pause for the 460 seconds. This is where I got confused. I just looked it up and I forgot. How many seconds was it? I think it was 460. It was 460, yes. So 460 is how long it takes to count to 1 second. Hopefully I can remember that for more than 1 second. So here we go. For T equals 1, 2, 4, 60, 40, next T, 50, next C for color. Here's our nested loop. And just for craps and giggles, we'll make this repeat infinitely. 60, go back to 10. So what does the loop look like? We're starting here on C. We're going to go from 0 to 8. We're going to go through all 9 colors. With each cycle, as we're counting through these colors, we will clear the screen to that number. As we've cleared the screen, we have now a nested loop inside here. I screwed that up. That's supposed to be next T. 40 should be next T. Let me do that again. Let's list that out. So we start by counting to 9 from 0 to clear the screen. We then count to 460 with the timer, which is exactly 1 second of waiting. And then we go to our next C, clear the screen again, pause for a second, and then I added in a bonus line which just says run forever. So let's run this and see what this looks like. Here's black for a second, green for a second, red for a second, blue. Okay, my palettes are off. Hold on, let me fix my palette real quick. Yeah, the palette is off. Here we go. Here's my palettes right. Now my palette is right. There's your purple, your orangey, peachy color, your green, your yellow, your blue, your red, your burgundy, your white, your other green, your purpley, your orangey, peachy. Those are the 9 colors. So it's actually cycling through all 9 colors, and it's pausing 1 second in between each one. So that was one of the DIY programs that it asked us to make, and that's pretty cool. That's not bad. We did it. Write a program that makes your computer show off each of its 9 colors for 1 second each. And if we wait till we get to black, we can count this again and see that it should be exactly 9. Black 1, 2, 3, 4, 5, 6, 7, 8, 9, back to black. Yeah, there's your 9 colors, there's your 9 seconds. So chapter 5, I thought we learned this word earlier, CLS, and nested loops. So chapter 5 dealt with loops again and timing, and it dealt with colors and timing. And you know what? It was not the most amazing chapter in this book, but we're learning a language, we're learning logic, we're learning how to think like a computer, we're learning how to talk to a computer. So it is all important things to know. These are all small building blocks. These are all pieces of a puzzle that will eventually be used to do more exciting things with your computer and giving you more control to have your computer do things the way you want them to be done. That's it. So I hope you enjoyed it. I have been the original gamer, Stevie Stroh. This has been Chapter 5 of Programming in Basic with the TRS-80 Color Computer, also known as the Coco. I hope you enjoyed it. If you did, then give this video a like. Give it a big fat thumbs up. If you got something you'd like to say, throw out a comment. Let me hear about it. If you're new to the channel, please hit that subscribe button and subscribe to the channel. And if you think there's anybody in the world who might enjoy this, share it with them. If you think they absolutely would not enjoy it and you want to punk your friends, share it with them anyways. So thank you for watching. I'll see y'all next time. Peace out and bye-bye. Long live the Coco. Coco forever.